Awesome. Hey, everybody. Thank you so much for joining us this month. Thank you so much also to those of you who joined us last month. We had a really fun webinar, and I'm really excited for this month. We have Sudarshan back on, and we're going to be talking about a really interesting topic around Kubernetes and container security, and that's going to be hunting detections from the control plane and the data plane. So grab your cup of coffee. We'll start in about 15 or 20 seconds. Yeah, I'm really, really excited for this month and really excited to share this topic with you all. Awesome. Well, it looks like people have started to join the call. Sudarshan, let's go ahead and get started into it all. Why don't you take a moment, introduce yourself?
Absolutely. Glad to meet you, Jeremy, again. I'm happy to collaborate and bring about some of the challenges that the industry is facing in terms of adopting Kubernetes and how we can help solve those security challenges. Been in Uptycs, been in the security space for the last 15 years, seen the whole security space evolve pretty drastically, and pretty excited to be here in the realm of cloud security space. Yeah.
That's awesome. Well, thank you so much for that introduction. Hi, everyone. I'm Jeremy. If we haven't met before, I'm a technical product marketer here at Uptycs. And yeah, prior to Uptycs, I did security engineering for a couple of years at Deloitte. And in my spare time, I enjoy playing and watching soccer. So let's go ahead and take a look at the agenda for today because we have some really great stuff to cover and a lot to cover over the next 25 minutes or so. So the webinar is expected to go around 20 to 25 minutes. We just did those introductions. So first off, thank you to Sudarshan. And next, we're going to break the webinar down into kind of two main sections and then an open Q&A at the end. So the first section is going to be talking about security across the CI/CD pipeline, really looking at pre-production security requirements and post-production security requirements, and really trying to understand what are the pain points and what are conceptually some of the solutions we can start to implement at the building, the testing stage, the deployment stage, and then ultimately the runtime stage for Kubernetes and containers. Then I'll hand it over to Sudarshan for really the fun stuff of the live walkthrough of the solution set, kind of hunting detections, hardening workloads, and really getting that UI feel. And then at the end, of course, we have an open Q&A. So any questions you have for myself or Sudarshan, feel free to ask them along the way, but we'll also have that time set aside at the end. So let's get started. So in this first section, like I mentioned, I want to take a look at kind of the CI/CD pipeline holistically. And we're going to talk about some of the pain points, some of the use cases of the developer, really building an image, deploying it, and then securing it in runtime. And then I want to break it down a little further and kind of talk about the specific pain points and solutions at that development stage and then at that runtime stage. So this image, I really enjoy this image. This is kind of an overview of a traditional CI/CD pipeline in a lot of ways. And we're going to look at this graphic holistically and then dive deeper into those two parts that we talked about earlier. So let's imagine on the left, you have a developer or a dev team building an image. Let's really tell the story here of a developer building that image, maybe using an open source library. They're working off of their developer laptop. How do they know an image is clean? In that building and testing phase, how do you tie in the vulnerability to the base image? How do we ensure that secrets aren't embedded into the registry? Are these images dynamically addressing these scaling compliance requirements? And you really need to address these questions in that development, in that CI/CD stage, to even have a chance at, by the time you hit the control plane and data plane, to have your image be immutable for deployment. After deployment into that control plane and that data plane stage, you really need to have a whole nother set of security requirements to really detect threats and ensure compliance. So Sudarshan, before we dive into each of these sections deeper, I'm just kind of curious, what are some of the pain points that we see when trying to secure across this entire CI/CD pipeline like we see here?
Yeah, no, absolutely. So one of the key challenges that we have been hearing from our customers is around how do you trace, given a CVE, for example, if there's a new CVE hitting the market, how do you know because of that CVE, which is, let's say, it's a score of 8 or 9 or 10 or whatever it is, right? How do you know which of my images are impacted, number one, and how many of those images are deployed in my container? Where are they deployed? Which cluster? Which workload? Which teams are responsible for mitigating that risk from a business perspective, right? So that's one of the key challenges that we are hearing on the vulnerability side. And of course, On the visibility side, we have been hearing about how do you get visibility into the networking piece of which service is talking to another service, or even how is identity playing a role into the Kubernetes RBAC system, right? There are multiple questions that customers are asking, but definitely the CI/CD is one of the big challenges that we have been hearing across the board.
That's awesome. And you touched on it a little bit, is kind of the struggle of network policies and really correlating data between the control plane and the data plane. And to give a little more context to this graphic before we move on, on the far left, you have the development stage. You move into the CI/CD stage where maybe you're building an image, you're testing that image, you're scanning your registry for compliance, and then you hit runtime. And in runtime, teams tend to split up their security tooling from a container and Kubernetes perspective into two aspects. First, that control plane layer where you have your orchestration or your runtime services like Sudarshan was mentioning. And then at the data plane layer, you have your actual nodes and containers themselves. And these have completely different requirements in terms of one getting that rich process event and socket event data versus one actually holding those network policies or compliance policies as well. So we'll talk about this a little more later, but first let's take a look at kind of a deeper dive into the CI/CD stage. So this is looking deeper at that pre-production stage. We have questions here as a developer. I'm asking, how do I ensure that my development team doesn't bake in secrets into our registry? I really want to make sure that there's no malware embedded into images. Attackers are also actually targeting pre-production resources increasingly lately. I've seen high-profile attacks like the recent Dropbox or LastPass attack. I've also seen the SolarWinds Sunburst attack from a couple of years ago, where attackers actually targeted build environments to embed malicious code into the SolarWinds build. And for me, one of the things I love to ask about here, Sudarshan, is from a developer perspective, or maybe even from a security perspective, as we're building and pushing images into the registry, how do we handle security around compliance or secret scanning for our base images and really get them ready for deployment? Because that's the core aspect here.
Yeah, now one thing kind of a best practice is before you check in anything into the registry, you just need to scan for any malware or secrets or any vulnerabilities as part of your CI/CD, as you alluded to earlier, right? That's something that we have to do. Let's say even if you push into the registry, how do you make sure if there's a new CV that comes into the while, and then now you have to rescan your registry for those CVEs, you need to do that in an automated fashion, right? Because CVs are coming every now and then, right? We need to make sure that registry is up to date, because you don't want to be static and then scan once and then forget about it. You need to continuously scan for those any new CVs that comes out, scan for the vulnerabilities in your images. And that's one part. The other part is not only that, before you deploy, you have to set some rules saying that, hey, if this image has certain CVE, I don't want to be deploying those images into my container environment. You have to block those being from deployed. So those are some examples that I can touch upon when it comes to the registry scanning and what you have to do before and after.
No, that's fantastic. And I think one of the things I hone in on there is the idea of kind of a seamless integration for DevOps teams to really enable them, that idea that, as things are dynamically coming up, new vulnerabilities are discovered, you need to make changes or you need to fail images or pass build images. It really enables teams to do that at scale. And the security aspect doesn't become a roadblock for these teams. At the development side, you want DevOps teams to feel empowered by their security solutions. So, one thing to kind of build off of what you just said, I'm curious, say everything is clean in the registry, but then that new vulnerability is discovered. How do we kind of handle that for a base image, and how do we address that new vulnerability?
Yeah, there should be always, of course, you can do scanning on demand. And as I said earlier, you need to, when there is a new CV as part of your workflow, you need to trigger an automatic scanning of your entire registry for images. And you don't have to scan the entire repository, right? You can have some intelligent way to pick only certain images, because maybe that package does not even exist in one of the images. So there are some different ways to scan. If not the entire registry, you can scan selective places to see if those are impacted because of the CVE, right? So, but all said and done, it has to be on demand. It has to be continuous as well, and making sure that you're always up to date in your base images specifically. And of course, there are some best practices on the base images. I'm sure everybody knows here as an audience, right? You need to make sure you do not have unnecessary package managers or SSH tools or whatever it is that is not even relevant for that image. Just remove it so that they are not vulnerable in the future point in time.
Yeah, definitely reducing the attack surface as well as we're thinking about these compliance standards and just kind of protecting in general. So thanks for kind of building that base for pre-production. But then when we hit runtime, I want to talk a bit about the struggles across the control plane or the data plane. And to give a little more context, I talked about it a couple slides ago, but teams often struggle with siloing security tools in runtime, especially for container and Kubernetes solutions, because there's this data plane layer and this control plane layer. So at the control plane layer, this is, like I mentioned, your orchestration or your runtime services. This is handling that compliance policies, network policies, the deployment phase. And at the data plane, you're getting all this rich socket and process event data from the actual running nodes and containers themselves. So when we see these, we often see them separately, but we're trying to bring them together. And Sudarshan, I'm curious, how do we secure the control plane and data plane separately, but also how do we start to bring this together and bring this data together?
Yeah, well, when you think about control plane, as you said, right, this is something. How do you lock down access to your control plane? That's very important when it comes to Kubernetes, because that's your keys to the kingdom, right? You don't want to provide keys to the kingdom of your entire cloud infrastructure or Kubernetes infrastructure. So you need to make sure there are some, like say, there's a pod security policy that you have defined, or even you have certain authentication and authorization. Enabling some of those controls, or even audit logging for that matter. You need to make sure you tighten your systems across the board. Think of it as a hardening for your control plane. That's really important, number one. And also continuously monitor for any changes that is happening in your control plane. That's really critical. That's the first part. When it comes to runtime, runtime is a very interesting topic, because oftentimes we would like to think containers are immutable. But most often, not most often, I think a lot of customers would love to make it immutable, but oftentimes the theory is different than practice. So it often comes down to a point where it's really not immutable, where there is some state change, there is some drift in your configuration, which is bound to happen. You need to be aware of those state change. It's number one, and make sure that you bring it back to whatever the pre changes were, right? So you need to have visibility, deeper visibility into your workload, into your container environment. Control plane is awesome, but at the same time, you need to protect your runtime, where containers are running, right? That's really important. And even, let's say, if there's anything that you want to do some analysis later on for your incident response team, you need to have some fingerprinting done, and you need to have some visibility into what happened in that environment, have a state of the environment. For provenance purposes, you need to store all that data in. So for that also, you need some visibility into your runtime. So all in all, when you bring these control plane and runtime together, you need to have a single unified data model. That's the crux of this whole problem. If you have disparate data models, then it's going to be a nightmare to correlate across these things. If you have a single data model, it's relatively simple. As I said, the first thing I talked about, how starting with the CVE, how do you map it back to the runtime containers? What containers are running where? How are they impacted? That level of visibility, that level of correlation is really important, and that can be done only with a unified data model.
No, that's wonderful. And I really like the way you said that as well, where the idea that using a unified data model makes the simple things easy, but it also makes the difficult things easy. Right now, if you silo your tools, it's really difficult to ask simple questions like, how does this vulnerability tie into a base image or deployed images? That simple level of visibility becomes extremely difficult for teams, either pre-production or in runtime. But if you have the right unified data model, you can ask these simple questions in real time and get these answers back. And it becomes easy. And then from that baseline, you can build the more complex, fun stuff that I know you're going to walk us through in a moment. But that fun stuff around threat detections, where you're putting together hundreds of signals across the control plane and the data plane. So I think it's really important what you just mentioned. Awesome. Well, thank you so much for that background on those different sections there, Sudarshan. I know you have some really fun stuff for the use case walkthrough. So I'm excited to hand over to you for the live demo. Anything you want to say as you take it over? Feel free to start sharing your screen now also.
Absolutely. Thank you, Jeremy. So while I try to bring up the screen, a couple of things that I want to touch upon is, when you think about Kubernetes in general, there are two personas, which is basic. One is the infrastructure team, the teams that manages this day in and day out. There is a security operations team. There is the developers who are interested, or DevOps or architects who are interested in making sure there is no vulnerabilities in their images. Think of it as three different personas. So what I'm showing here is specifically targeted towards operations point of view, where if you're trying to manage it from a SecOps perspective, right, how do you do it? So this is kind of what we described as visibility. One of the key challenges that the market is facing is how do I visually see how are these clusters and nodes and namespaces connected? And how do you know which one to act upon, right? How do you prioritize that? That is one of the things that we have constantly heard from our prospects and customers. So I just want to walk you through what we have right now. What you see here is it could be AKS or it could be GKE from Google, or it could be your Amazon EKS. Right now, there are three different samples that we're showing. And it will also tell you on a per cluster level, to give you how compliant you are, what are the vulnerabilities, what are the threats in those specific cluster. Now, right now, I'm drilling down into one specific cluster, which is here as a GKE. So as you can see, here are the 7 namespaces in my GKE cluster, and this is purely an infrastructure view. Now, what happens is, how do I make it more actionable, right? So if I click on vulnerabilities, it will tell you right away that out of these 7 clusters, 7 namespaces, 3 of them are something that you have to drill down further. And then based on the number of alerts that you see, 319 or whatever, you can prioritize and say, okay, I want to drill down this on this specific namespace called default. And I click on it, it will show you what are the pods that are deployed in that specific namespace. And within that pod, which pod has more alerts based on inventory that we collect. And within that, if I want to pick on, let's say I'm more concerned about the pod that has a higher number of alerts, I can drill down and find out what are the containers running in that specific pod. So in this case, I have the container actually, and then what are the images from which the containers was deployed on. So you get the image name itself, and you can see all the context as and when we go through it, the context changes based on whether you're looking at the namespace or a pod or a specific container. If I want to know what specific this is a container, I click on the container, it will tell you all the details about that container. For example, what are the namespace it is in, when was the container last launched, how many vulnerabilities are there in that container, is that container running as a root? So you get the depth of information and telemetry about containers starting from the previous screen that we talked about. From a very high level view, you start at the macro level view, and then you go drill down deeper to the image level view, and the context around all the details about that images, you have it on your fingertip. So that is the where we provide visibility from a customer standpoint. Visibility is not only for vulnerabilities, and also threats as well. If I move to threats, it can tell you which out of these 7 namespaces, which is more has more threats than the rest of them. Now you can click on it, go to the threat view as well, and see what is happening in that specific container. So I click on that. It will tell you, is there any specific threats that is happening? As you can see here, there are multiple alerts that came because in that related to that container, you can get all the details right here in your fingertip. So that's one view that I want to share. The other one is around, this is on the infrastructure persona or infrastructure team or your SecOps team. Now, switching gears a little bit, if I'm a developer or DevOps or a cloud architect, I'm more worried about how are my images, are my images vulnerable, and where are those images deployed, and what kind of vulnerabilities are there, right? So in that regard, the best way to get that going is around, if we go to this page here, I can see, I want to look at the vulnerabilities. Starting with vulnerabilities, I click on, and I see the top 10 vulnerabilities that I have to fix today, right? So when I click on the vulnerability, so it's a CVE score, this is a score of 9.8, and this is a CVE ID. I click on this, and then it'll tell you what are the specific vulnerabilities, and what are the images affect, how many images are affected because of that, and the associated metadata around it, right? So when I click on a specific vulnerability here, it'll tell you that vulnerability, what are the images that are impacted because of the vulnerability. As you can see here, this is a specific image that is impacted because of this vulnerability CVE 202.1292. And I click on that image, it will tell me where is that image deployed, which cluster is it running in, and which namespace. So as you can see here, that image is running in this cluster protective EKS and is running in, and this is the namespace. And to give you all the details about what are the number of vulnerabilities, how many critical vulnerabilities are there in that image. So you get that connection of starting from your CVE. You can drill down to find out what are the images affected and where are those images deployed in my environment as a customer, as a DevOps person. Now I can go and fix that image. If it is running in a very important namespace or important cluster, production cluster, my first thing that I have to do is go and try to remediate that, right? So that is the view that we provide when it comes to vulnerabilities. And switching gears a little bit when it comes to, let's say, a compliance person, right? Or even if you're an infrastructure person, you're trying to make sure you harden the control plane in terms of securing the control plane, right? So we touched upon this briefly around the NSA hardening guidelines. NSA came out recently in the middle of the year around set of controls around multiple categories. For example, they talked about best practices when it comes to pod security policy. They talk about network separation and hardening. They talk about audit logging or even authentication and authorization, right? So as long as you have a very solid control plane hardening done, you're kind of meeting a lot of security goals, security objectives in terms of protecting your Kubernetes and containers environment. So we do enable in terms of providing those roles. So as you can see here, we support multiple standards when it comes to Kubernetes control plane around PCI, SOC 2, CIS, and even NSA. So if you think about NSA, so that's basically, as I said, there are multiple policies that we have. Think about if you want to deny a container that is running, that is with host PID access, or you want to deny containers that are that can have host network access, right? Another example is if you think about network separation, you do want to lock down access to the control plane using your RBAC access, or do you want to control it through? You do not want to allow anonymous authentication into your environment, right? You have to disable this anonymous authentication. Or there are multiple policies that NSA defines across these 7 or 6 key categories. We have made sure that those rules are available for our customers to use it so that they can harden the control plane, right? So we talked about the visibility part, where how do you, as an infrastructure person, how do you get that top to down deep details about your environment across your threats, vulnerabilities, and infrastructure view. And then we kind of talked about, if I'm a DevOps person, if I really care about the vulnerabilities and understand which images are impacted because of the vulnerabilities, we do scan it, we do provide the reports, and we do integrate with CI/CD tools like Jenkins, GitLab, AWS Code Pipeline, and all this, right? We do integrate it, and you can trigger your build, or you can fail your build based on if a specific image has certain vulnerabilities within it. You can fail it in terms of syncing it to your repository registry, or even once you download it from registry, you can even stop it before getting deployed into your production environment. Going back to what Jeremy talked about earlier, the control plane and the data plane. How do you prevent rogue images from being deployed into your data plane? That's how you do it. For example, you can go into the deploy profile. You can create your own profile and then say, hey, I want to add a rule stating that if the CVE score or the image name or image tag or whatever it is, you can create multiple conditions and create a rule. And then you can also have some exclusion rules. And then automatically what will happen is this deployment profile is loaded, and we basically try to limit the deployment of that container based on the rules that you set. This is something that we have using OPA. So just want to touch upon that as well. So the other thing is if they do not have managed containers, you can also, if you have a self-managed model, we do support the self-managed container model. We again help you prioritize vulnerabilities, threats, and compliance issues, and you get an overall inventory view about your container environment. So over to you, Jeremy.
No, that's fantastic. Thank you so much for walking us through all of that. And one of the things that stands out for me just right off the bat is like you mentioned, getting that macro view and that micro view all in one. So the idea that if you have the right data, it becomes easy to do what you walk through, where you get like that cluster level visibility, you get an understanding of, okay, what's my actual security risk posture? But then within a click or 2 clicks, you're in a specific image, you're seeing what specific vulnerabilities need to be addressed, what applications are running on this container. So really, really interesting, and kind of spreading that out, not just in a vulnerability sense, but the compliance side as well, or even threat detections as well, is really fun stuff. So thank you so much, Sudarshan, for walking us through all that. Folks, I want to open it up to the Q&A. I saw a couple of questions trickle in, so I'm happy to take those as anyone else who has a question, feel free to put it in there. But Sudarshan, maybe you take this first one. This question was, can you expand on the threat detection side? What is important about unifying the control plane and data plane data? Yeah, so maybe, Sudarshan, if you want to talk a little bit about what it takes to unify that data across the control plane and data plane, and maybe why we took this big step forward in trying to unify that data together for detections.
Yeah, the one of the thing is we cannot look at control plane and data plane in isolation, because at the end of the day, if you have an orchestration layer, whether it's a managed one or your own orchestration layer, you need to have insights into how is a container being deployed. And as I mentioned earlier, hey, there are different configurations and misconfigurations that you can have in your control plane that you may not be even aware. Because of that, an attacker could get into your runtime environment, right? So having that correlation between control plane and data plane is critical to detect any incident or even be more proactive in terms of trying to avoid those kind of threats in the future, right? So we need to make sure you have to bring those two together. To bring those two together, having a single unified data model is going to be very important, because correlating is a very expensive operation, right? You need to be aware how you're going to correlate, and then to reduce your false positives, the correlation, how you correlate is going to be very important. So that's why having those two together and bringing both the planes together is important in terms of detecting threats within the container environment, Kubernetes and container environment.
That's awesome. Yeah, thank you so much. Okay, so I saw one other question as well around secret scanning. So maybe we can expand a little bit here on, what are the secrets we're actually scanning for in the registry? Can we give a couple of examples maybe?
Yeah, we scan for 100+ secrets. One of some examples are, let's say there is an AWS API key that you use for your developer that is somehow baked into your image, and it gets uploaded into your registry, which is open registry, for example, right? Then we want to make sure we fail that image from being pushed into registry or even being deployed into your production environment. So AWS API key is one example. We look for PII data. You look for your credit card, your SSNs. There are multiple things that we look for, but these are some of the examples that I can think of on top of my mind.
Awesome. Well, thank you so much for those examples. And also big thank you to those of you who joined us this month. If you have any other follow-up questions, feel free to email me or Sudarshan after this call. We love talking about this stuff. We love talking about security issues in general. So feel free to drop us an email or just contact us however you want. And thank you so much for joining. Any final thoughts before we close it out today, Sudarshan?
Nothing specific. Just we understand the challenges you go through when you try to do app modernization, especially when you do manage instances on, and security is going to be very interesting and challenging for you guys. So we want to learn from you and then help you navigate that security grief.
Awesome. Well, thank you so much. Have a great rest of your day. Have a great rest of your week. And thank you so much for joining us.